In this video, we'll be taking a look at the Lesson 6 packet for Bootstrap World, specifically pages 1 through 4. So this is the Part 1 video for Lesson 6. So let's get reading. Example, a rocket blasts off traveling at 7 meters per second. Write a function called rocket height that takes in the number of seconds that have passed since the rocket took off and produces the height of the rocket at that time in meters. So let's take a look at letters A through F. What is the rocket's height after 0 seconds? So we need to think about this speed, which is listed as 7 meters per second. After 0 seconds, of course, the rocket has gone 0 meters into the air. Letter B, what's the rocket's height after 1 second? Well, after 1 second, the rocket will have traveled 7 meters. If it's 7 meters per second, then after 1 second, it's gone 7 meters. What's the rocket's height after 2 seconds? Well, if it goes 7 meters in the first second, 7 meters in the second second, that's a total of 14 meters high. We start to notice a pattern here. The rocket's height after 3 seconds will be 7 plus 7 plus 7, which is 21. After 4 seconds, 28 meters. After 5 seconds, 35 meters. We start noticing a pattern here. The pattern is that we take the number of seconds, which in this case is 0, and multiply it times 7. 0 times 7 is 0. Here, the number in letter B, the number of seconds is 1. 1 times 7 is where we get our 7 from. 2 seconds. Well, 2 times 7 is 14. That's where we get our height from. 3. 3 seconds times 7 meters per second is 21 meters high. And the pattern continues. 4 times 7 is where we got our 28. And of course, 5 times 7 is where we got our 35. So in letter G, it says mathematically, how can we compute the rocket's height after X seconds? So instead of using specific numbers like 0, 1, 2, 3, 4, 5, we are going to instead just use the variable X. So X times 7. Or we can, of course, rewrite that as 7X. So let's take a look at the last couple questions on this page and see where this is headed. Letter H, what's the name of this function? Back up above in the word problem, I highlighted, they told us that the function is supposed to be called rocket height. Now notice these are all lowercase and there's a hyphen in between the words rocket and height so that the computer actually reads that as one word. Okay, letter I, what's the domain? It says that the function takes in the number of seconds. So of course the domain is a number. What is the range of this function? It says the function produces the height in meters. That also is going to be a number. Okay, so based on parts H through J, the contract for this function is, contract always starts with a semicolon, then comes the function name, then a colon, the domain, which is number, and then an arrow producing the range, which is also a number. So the whole point of this and where this is headed is we're going to be talking about purpose statements. So to give more information than is given in a contract, programmers write purpose statements, which are simple sentences that explain what a function does. Often the purpose statement is just a restatement of the word problem. We'll try a purpose statement for rocket height on the next page. So let's go ahead and take a look at the next page. We are going to be completing the contract and now a purpose statement, still with 2 examples and a definition like we've been doing in our previous lesson. So this word problem is exactly the same. The function is called rocket height, takes in the number of seconds, produces the height of the rocket at that time. So a lot of this is going to be repetitive, or at least the contract will be repetitive. So rocket height is the name of the function. The domain is a number. The range is a number. The purpose of this function can actually be a restatement of the question. Or once we discovered this pattern here on the first page where we're taking the number of seconds and we're multiplying by 7, that might be a good way to describe the purpose of this function. So I might say something like multiply the number of seconds by 7. That's what this function is going to do. It's going to take in a number as the domain it's going to multiply that number by 7 to give the range or the output. So for example, when I type into the computer rocket height, and I'm just coming up with a random number here, I'm just going to choose the number 5. These are examples, so we're using specific inputs. When I type in rocket height 5, I want the computer to actually multiply my number, which is 5 times 7. So that's my first example. Second example, everything is going to be staying the same, except you can get creative with one thing. The only thing that can be changing is the number that's used as the input. So instead of 5, let's use 11. What's the computer supposed to do with the number 11? Well, it's supposed to multiply 11 times 7. So those are two examples that we can use to basically teach the computer how to do this rocket height function. So remember, at this point, we circle the changeable parts of the examples and then come up with the variable name. So the only part of these examples that are changing are the specific number that's used as an input, the 5 and the 11, the 5 and the 11. Those are specific numbers. Let's use a variable to represent that. What are the 5 and the 11 representing? They're representing the number of seconds that have passed. So I'm actually going to use the variable seconds. So when we go to write our definition, we still have the name of our function, but instead of writing a specific number, we're using our variable, seconds. On the second line, which would actually be the second box when we're typing in the computer, we want the computer to multiply whatever number I'm using for seconds times 7. That's my definition. When I type this in the computer, I'm actually going to do this at the end of the video. When I type it in, we should be able to use the rocket height function to calculate the height of the rocket after any number of seconds. We're going to be testing how high is the rocket after 20 seconds and how high is the rocket after 5 minutes. So let's think about that. If 5 minutes is the given time, that's obviously not in seconds. How can we turn 5 minutes into seconds? Well, we can take 5 and multiply by 60, which is actually 300 seconds. So when we get to letter E here on the bottom of page 2, we're actually going to be testing to see what's the rocket's height after 300 seconds. So we'll be doing that at the end of the video. But let's take a look at page 3. Complete the contract, purpose statement, 2 examples, and definition for this red square function. So use the design recipe to write a function called red square, which takes in one number, which is going to be the size of the square, and outputs a solid red square. So it says that the function name is red square. It takes in a number, so the domain is a number, and outputs a picture of a square. That's going to be an image. The type of data that's in the range is an image. So when we have to write our purpose statement, you'll notice right down below this line it says, what does the function do? We want to describe in our own words, what does this function do? I would say it creates a solid red square of any size. We are going to be choosing the size. That's where this function will be useful, is we can create a bunch of red squares, but they can all be different sizes. So let's take a look at our 2 examples. I'll do the first example, and then I'm going to have you pause the video and do the second example on your own. So the function name is red square. So when I type in red square with a number, let's say size 30, I want the function to produce a square. Remember, that's a function that the computer already knows. The computer will be able to understand what I'm talking about because I'm using a function it's already been taught, basically. So I want to create a square, size 30, based on what I just wrote there as my input. I want it to be solid, and I want it to be red. Close the parentheses. So go ahead and pause the video now and try the second example on your own, keeping in mind the only thing you're changing is the 30. So let me go ahead and throw up an example here. You can check it. Maybe you use the size 100. That's great. Or any other number. Still a square, whatever size you chose. It's still solid. Remember, that's in quotation marks, and it still has to be red. That also has to be a string in quotation marks. So now we circle the part that's changeable and come up with the variable name. So what are the 30 and the 100 representing? Well, it's a number, but it's actually representing the size of the square. So I'm going to use the variable name size. So when we get to our definition, we're keeping everything the same, except instead of using a specific number, we're using the variable that we've chosen for that input, which in this case is size. What does the function do with that variable? Well, it's supposed to create a square, size, whatever size I use, whatever size I told it. It has to be solid, and it has to be red. So that's my definition. At the end of this video, I'll be typing that in using the recipe button, and we will be able to create a red square any size we want by using the code, for example, red square 55. But let's move on to word problem number 3. This is our last word problem before we start typing. So this one is a little bit different. It's called yard area, and the directions say use the design recipe to write a function called yard area, which takes in the width and length of a backyard and returns the area of the yard. So there's actually 2 inputs here. It says it takes in the width and length and returns the area, remembering that area is length times width. So the function name is yard area. There are 2 inputs, and they're both numbers. Okay, the length would be a number, the width would be a number. So number, and it produces the area. The area is still going to be a number. So when we get to the next line where we are writing the purpose statement, we need to keep this formula in mind, because mathematically what this yard area is supposed to do is it's supposed to multiply the length and the width to compute the area. So that's my purpose statement. You can word it a little bit differently and it's still okay. Let's take a look at some examples. I'll do one example and then I want you to do the second one on your own. So when I type into the computer yard area 5 space 10, remember 2 inputs are needed here and they both have to be numbers. What do I want the computer to do with the 5 and the 10? Well, if area is length times width, I want it to multiply 5 times 10. So go ahead and do the second example on your own. Pause the video now. So I've put down an example, a second example of the yard area function. I used 7 and 3 as my inputs. You can use anything you want, any 2 numbers. We find here that not only is the first input changing, but also the second input. So we actually have to circle 2 different things and give them 2 different variable names. So I'm actually going to call these length and width. So length for those, and width for those. You could call them A and B. You could call them X and Y. You could call them just L and W, which would be a shorthand for length and width. But when I write down yard area, instead of writing down 2 specific numbers, I'm writing down length, width, and on the second line, what do I want the computer to do with those 2 numbers? I want it to multiply whatever the length is by whatever the width is. So let's get typing. Let's go back to word problem number 1, which was rocket height. So at this point, if you can actually go to wescheme.org yourself and do the bottom of pages 2, 3, and 4 on your own, that would be the best. But in the next minute, I am going to be showing you all 3 of these. So bottom of page 2 tells us to use the recipe button to type in the contract, examples, and code for the rocket height function. So I'm going to pause the video and do that, and I'll be back in a second. Now that I've filled in the recipe, I'm going to click Insert. And one of the things you need to do is make sure that you type in the purpose statement. So starting right underneath the contract with a semicolon, I'm going to write out the purpose statement. Multiply the number of seconds by 7. When I click Run, I should now be able to complete the rest of this page by typing in rocket height 20, for example. That means the rocket will be 140 meters high after 20 seconds. How about the other one, rocket height 300? 2100 meters. I'm out of time, so we'll finish this up in the next video.